Okay, so this video is going to be about the fifth part of our perfect competition coverage, right here, shifts in the graph. So there is another video that goes over what we did in lecture, which is defining perfect competition, giving some examples, talking about why the demand for perfectly competitive firms is perfectly elastic, and therefore price is equal to demand, which is equal to marginal revenue. And then introducing the graph. Talking about the two panels, using marginal cost to derive the optimal individual quantity, and using average total cost to derive profit, average variable cost to discuss the shutdown decision. We're going to be starting from long-run equilibrium. So assuming that the market is perfectly competitive, the average person is not making any profit, and then seeing what happens when something shakes things up. So the shifts in the graph are not well covered in the book, which is why we're going to emphasize them in this video and then do a little bit of group work. There's basically 6 different types of shifts that I'm going to show you. The first is where demand goes up, and that is covered in the book. The second is where demand goes down, and that is what I'm going to show you in the first part of this video. The third possibility is that supply goes down. So that would be the global or larger market supply going down, and importantly, not affecting the costs of the individual. We're trying to make our lives easier by only shifting one curve at a time. So I'll talk about what that looks like in problem set number 6. Or supply could go up, and that is something you'll be doing in class together on Monday as part of group work. The other 2 alternatives are that an individual's costs go down, which we'll do in the second part of this video, and it's an event that's not large enough to shift global supply, or an individual's cost could go up. So just to reiterate what we're doing, will be very similar, I'm trying to figure out how to show this, to question E on problem set 6. The only change will be what I've crossed out. Describe a shock that would decrease the global demand but not shift the cost curves of the individual producer. And then part F. Use a graph to explain the short run and long run consequences of the shift in part E for the larger market and for the individual firm. Make sure to show the short run profit or loss on your graph and explain what brings the market back into long run equilibrium. So that's the question that we're answering right now. So the first step is to draw our graph. I'm going to keep track of our short run and long run consequences down here at the bottom because that's another thing that the question asked us to do. But we're supposed to use the graph to analyze the shock. So again, this is going to be demand falling in perfect competition. That's the graph we're drawing today. Demand falling in perfect competition. We want to first start from the long run equilibrium. So in perfect competition, we have the larger market over here on the left. Let's think about salmon again, just like we were in class. So this is the global salmon market. And this market is comprised of very normal looking supply and demand curves. You don't have to worry about elasticity. I'm not going to try to think too hard about what these curves look like. Just draw some regular looking supply and demand. But I am going to be careful about labeling because a lot is about to go down, so we want to know where we started. This is where we started. This was the original Q star G, global equilibrium quantity of salmon being bought and sold. Corresponds to the initial global equilibrium price. You could just call that P star, you could call it P star global. It's going to be the price for everyone in this market. So remember, we're not done because in perfect competition, this is a two-way graph. We have the global salmon market and how it affects our individual salmon harvester. Over here on the right. Let's call him Gusty, after my favorite Caligonic salmon harvester. So Gusty takes the price from the larger global salmon market. Because he's a perfectly competitive firm, his product is the same as everyone else's. It's very easy for other people to go in and get fish. It's very easy to farm fish and have it be sold for the same amount as wild salmon, he is a price taker. So this global price becomes his price, but it's also his demand curve, perfectly elastic. Let's say this is 50 cents a pound. If Gusty charges 51 cents per pound, his quantity will be 0. So the x-axis of this graph gives us the individual quantity, and the y-axis is just in dollars. We would call it dollars per unit, dollars per pound, because this graph is going to include both costs and price. That means the y-axis is not just price as it is in the graph on the left. Just a small distinction, but remember the real difference between these two panels is this has everyone in the entire world that eats and fishes for salmon. This is just one guy, right? One harvester way up in rural Alaska. Taking the global market price as given, that price becomes Gusty's demand curve. It's also his marginal revenue. Every single salmon he sells is going to bring in 50 cents a pound. He's such a tiny drop in the bucket that he can provide 100,000 fish and not make a dent. Each of them will sell for 50 cents a pound. Right? He has no control over the price he accepts from the market, but he can sell as much as he wants to at that price. Right? But he will not fish for 100,000 pounds, probably. It will depend on his marginal cost. So looking back at the way we first graphed this, remember for the individual, the most important, the Beyonce of the cost curves, is the marginal cost. It's going to tell us how much that individual should produce, the profit maximizing quantity for the individual, QI star. And QI star is going to determine their level of profit, whether they should shut down or not, so we really have to find that quantity first. So you can put Gusty's marginal cost curve in anywhere. Marginal cost. Any old Nike swoosh, anywhere you would like. Gusty's going to produce where marginal cost is equal to marginal revenue. He follows the golden rule, just like everyone else. Right? In every market structure, that will hold true. Marginal cost equal to marginal revenue. Gusty would never produce to the left of that because each fish is bringing in more than it costs to catch. So he will keep going until diminishing marginal productivity means the cost of each fish is more than the revenue it brings in and it's not profitable to catch that fish. Right? So this is going to maximize profit right there. The next curve that we need to draw is average total cost. And unlike marginal cost that we could draw anywhere we wanted, there is only one place that average total cost can be in the long run of perfect competition. And that is where profit is 0. Right? Because in the long run equilibrium, people would have entered or exited until profits were 0. So average total cost, we know 2 things about it. It has to be equal to price because that will make profit 0, and it has to hit marginal cost at its minimum. So that means it sits its cute little average total cost but right down there on the demand curve, and it hits the marginal cost curve at its minimum. This is our average total cost. Things are already getting crowded. Don't crowd them further by drawing average variable cost or average fixed cost, right? When I'm asking you a shift question, I typically don't care about those curves at all. Don't put them in unless I ask you something about the shutdown decision, because they're just going to make your graph more crowded than it needs to be, okay? So now, going back, we've got our long run equilibrium graph. This is what you should start from every single time you start a shift problem. Right? This is the baseline. You will get some points just for being able to replicate this. But now something has happened. The question might say, explain an event that would decrease the global demand for this product and not affect Gusty's cost, right? It's really just decreasing demand. So that could be something, let's say, what would make demand for salmon fall? Let's say there is a highly publicized, let's just say that the price of chicken drops. Really need another thin marker. Price of chicken falls, right? That's a substitute for salmon in consumption. So that means that the demand is going to fall for salmon. Where do we see demand for salmon? Well, we see it here, but we also see it here. This is going to affect the global salmon market, not just Gusty. Gusty is going to be indirectly affected as a price taker. So the first thing you want to do is show demand shifting down. That's what happens when a substitute gets cheap, right? At every price, people want to buy less salmon. They're switching over to chicken. So first round of consequences, demand falls globally. That pushes the global quantity down, less salmon bought and sold, and the global price down. Right? That is all short run for the global salmon market. Now that's going to spill over to our individual harvester. When the price falls for everyone in the salmon market, his price will also fall, meaning his demand is lower, his marginal revenue is lower. As a price taker, he can't control the fact that less people want to eat salmon. So in addition to all of these global consequences, the price of the individual also falls. How is Gusty going to react to that? Well, when there's a lower price, marginal revenue is equal to marginal cost at a lower quantity, right? Now it doesn't make sense to fish for these units of salmon right here. Now he wants to stop fishing sooner because all of these fish are going to cost more than they bring him on the market. So when he is paid less, he behaves according to the law of supply. The individual fishes less when they're paid less, right? That makes sense, hopefully. The last thing that we need to calculate is the short run impact that this chicken price falling has on Gusty's profit, right? So we want to look at this new lower quantity. How much profit is Gusty making? Remember our measure of profit? It's P minus ATC multiplied by Q, right? Total revenue minus total cost. But the way we see it in our per unit graph is the price you're charging minus all of the costs at that price multiplied by the number of units. So we know Gusty's price is right here, right? We know his average total cost will come from the quantity he's producing. We follow the quantity he produces all the way up to the average total cost curve, right? It's where that quantity has nothing to do with the original black price line. It's where that quantity bounces off of the average total cost curve. Now that he's fishing less, his costs per unit are actually higher, right? He's spreading his fixed costs out over less units. And the profit rectangle is the vertical distance, P minus ATC, multiplied by Q, the number of units. It's that box right here. This is not a profit though. This is a loss, right? Because ATC is bigger than price, this whole thing will be less than zero. So we have profit less than zero. Short run consequences. That is the end of our story in the short run. All of this in blue is short run, SR. That's where the story ends in the short run. But in perfect competition, the short run is never the end of the story. The long run is always about either entry or exit. So long run consequences in green is that if the average individual is losing money because now everyone's eating chicken instead of salmon, people start exiting. So we have exit. So remember Gusty, he's an interesting guy, but he also represents just the average participant in this market. And if the average person is making a loss, people start exiting. The person with the largest cost is going to exit first, but people are going to exit in quick succession until the market gets back to equilibrium. You can think of each person that exits as marching this supply curve back to the left, right? Reducing the quantity supplied at every price. Because one of our determinants of supply, going all the way back to chapter 3, was the number of firms, the number of suppliers. So each person that exits pushes the supply this way, right? They start shifting the supply curve. I don't want to mess up my graph by having a million tiny little supply curves, but you can imagine a bunch of little supply curves lying to the left until, boom, we reach this magic point. And that's the point where the price is back where it started. We need that because that's the only price that's going to get us back to zero profit. So after exit, the global supply falls, right? The number of suppliers is falling. The global quantity is down to lower than ever, and the global price is back where it started. You could call that P double prime. That's for the larger global market. Sorry, we should be specific that when we say quantity falls, we mean global quantity, because Gusty's going to have a different reaction. The global quantity falls, the global price goes back up because there's less competition in the market, which means every individual who is left can charge a higher price, right? So Gusty sees that higher global price coming from all the exit. We hope he's one of the lucky ones that stuck around. So he gets to benefit from the impact of everyone else leaving the market, and his price goes back to where it started. Okay? Back to the black line. The price of the individual goes back up. Marginal cost is now equal to marginal revenue at the same place where it started. Gusty stops producing less and produces the same amount again. The individual's quantity goes back up. All of the salmon harvesters that have left, that have weathered this demand shock, are going to be producing a larger share of the remaining global quantity. And this should always be your punchline. Profit is zero again. I have to use my thin pen to write again. Profit always goes back to zero in perfect competition. You can think of these tiny little boats on a big fluctuating global ocean that are always being bounced around this zero profit point, but returning here inevitably in the long run. Okay? Because of the forces of entry and exit, there's no barriers to getting in and out. We have to assume it's very, very easy to sell your boat and your nets, and that there's no permits, right, keeping people out. That means that when there's a shock to demand, people leave, and the people who are left are no worse off in the long run. Now that long run could take a really long time to get there, right? So you could see loss for quite a while. That doesn't mean that chicken prices falling isn't devastating to some producers and forces them out of the market, but it does mean that the freedom of entry and exit always bounces us back to zero profit in the long run. Okay, so that is a demand shock. Let me take a break, erase all of this craziness, and I will show you what a change in cost looks like.